Before we get into today's lesson, it would be a good idea if you once again review the unit circle and make sure you understand where the different angles are located, in what quadrant, and what type of angles result in positive numbers versus negative numbers for those ordered pairs. So if we were to look at the unit circle, this is what it would look like. So if you need to, pause the video and write this down again, but we need to be familiar with this, okay? Because this is going to be used in today's lesson. So let's dive into today's lesson. Today we're going to be looking at section 5.7, which is all about inverse trig functions. So today we're going to understand and use inverse for both sine, cosine, and tangent functions. And then we're going to be finding exact values of composite functions with inverse trig functions. All right, so remember, the unit circle helped us with our graphing. And so we're going to kind of relate this graphing to what we're doing today as well. So the inverse sine function. By looking at the sine function over here on the right, if I'm looking at the graph and I draw a horizontal line through that function, it does not pass the horizontal line test. And what that means is that we don't have an inverse. Okay, so it's not going to have an inverse function when it doesn't pass the horizontal line test. However, there is a way for us to get an inverse, but what we have to do is we have to restrict the domain. So we have to take just a chunk or a small portion of that sine graph. And so notice that the portion that I took needs to be on the left of the y-axis as well as the right. And because that little section crosses or touches passes the horizontal line test, that little portion will then have an inverse. So if you look to see what those values are on the x-axis, negative pi over 2 to positive pi over 2 would be those values. Those are going to be important numbers for us. Okay, so here's that then formal definition using those pictures. So it says the inverse sine function, which we always write as sine to the negative first power, is the inverse of the restricted sine function y equals sine of x, but its negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. Okay, remember, when you have an inverse function, that means that you flip the x and the y values around. So when we have y equals the inverse sine of x, it really means that the sine of y equals x. So that means that it's the y values then that have that restriction. So negative pi over 2 is less than or equal to y, which is less than or equal to pi over 2. And then that means that we have negative 1 is less than or equal to x, which is less than or equal to 1. The reason why we have these number ones and negative ones is if you're thinking about the unit circle, the biggest and the smallest number that sine could be is 1 and negative 1 because of the radius of the unit circle. Okay, so we read y equals the inverse sine, or sorry, sine to the negative first as y equals the inverse sine at x. Okay, so having that domain from negative pi over 2 to positive pi over 2 is going to be very important. Okay, so let's just once again kind of relate it to the graph. So one way to graph that y equals inverse sine of x is to reverse the ordered pairs. Remember, we did that before when we were graphing inverses. So on the left is my original function, y equals sine of x. Okay, so notice that my x values are all of my radian numbers. My y values are all of the highest and lowest point would be because of the radius of that unit circle. But notice that on the right, when I'm dealing with my inverse function, notice how it's the x-axis that now goes from negative 1 to 1, and it's the y-axis that deals with the radian values of negative pi over 2 to positive pi over 2. Now, we're not actually going to be graphing inverse functions, but we're going to be calculating them. And we're going to be doing this without a calculator, but I just wanted you to kind of understand the overall picture of these things. All right, so let's dive into some examples. Like I said, we're just going to be calculating them. And so we're going to be doing this without a calculator. So it says, let's find the exact value of the inverse sine of the square root of 3 over 2. So the whole point is that these problems, because we have this -1 power here, remember inverse means that you're trying to find an angle measure. So my final answer is going to be a radian value. All right, so if we remember the definition that I just talked about, because we're thinking about the graph, we had to restrict the domain. So essentially that means that my answer has to fall within the range of -pi/2 to +pi/2. So anytime we're thinking about inverse sine, this is the range that we need to be thinking about. If my answer is something bigger or smaller than these values, then we have a problem. So now what I want to do, now that I know that this is my range, if you're thinking about your unit circle, that means we are going to be thinking about, remember, negative angles, we're going in a clockwise position. So -pi/2 is down here at the bottom. We're going in a counterclockwise position for positive angles. So up here is +pi/2. So it's everything over here on the right side. And so we're thinking about quadrant 1 and we're thinking about quadrant 4. Okay, so inverse sine, we're thinking about those two particular quadrants. And so now what I want to do is I want to focus on the the fraction that's given to me, because this is going to tell us which quadrant we fall in. Okay, so if you think about our saying, remember, all students take calculus. Well, in this particular case, since I'm only focusing on the first and the fourth quadrant, if I'm dealing with a positive ratio, that's when sine has to be in the first quadrant, because only cosine is positive in the fourth. So that means that I'm going to sketch a picture of a right triangle where my right angle, once again, needs to be on the x-axis. This is my theta. That is what I'm trying to find in this particular problem. So now that I know that I'm focusing on the first quadrant, my ratio, if I'm thinking about SOHCAHTOA, sine is opposite over hypotenuse. So the square root of 3 is opposite the angle I'm trying to find, and the hypotenuse is 2. So what kind of special right triangle deals with those two sides? Well, it's going to be a 30, 60, 90 triangle. We just have to figure out, is that going to be a 30-degree angle or is it going to be a 60-degree angle? So when you are across from that as the square root of 3, remember that's going to represent then the 60-degree angle. So the last thing I have to do is not write 60 degrees, but I have to write it as a radian value. So that's why we have to know our radians. Remember, 60 degrees is the same thing as pi/3. And that would be my final answer. Okay, so if we take a look at this next one, we have the inverse sine of -2 over 2. Once again, because we're dealing with the inverse, that means we're trying to find an angle measure. And when we're dealing with sine, we're dealing with the restriction that we have to have an angle value in between -pi/2 and +pi/2. So once again, going back to the first problem, that means we're either in the first or in the fourth quadrant. Now notice that this time, the ratio that is given to us is a negative ratio. Remember, in the first quadrant, that's where all of the ratios are positive. So because this ratio is negative, that tells us that we are going to fall in the fourth quadrant. So I get to draw a right triangle where, once again, theta is what I want to find. It's always formed with the x-axis. My right angle is always drawn to my x-axis. Okay. If we think about then my ratio here, we're trying to once again figure out, are we dealing with a 30, 60, 90 triangle or a 45, 45, 90 triangle? So hopefully you notice that because we're dealing with a square root of 2, we're actually going to be thinking about a 45, 45, 90 triangle. And actually that is rationalized for us. So technically, this is the equivalent, okay? -1 over the square root of 2. Because remember, you'd multiply both the top and the bottom by the square root of 2 to get that -√2 over 2. Okay, so I do actually want to think about it in terms of before it's rationalized, because once again, if we know that sine is opposite over hypotenuse, well, opposite is where that square root of 2 would be. But because the hypotenuse is 1 and the hypotenuse has to be positive, hopefully it makes sense that it's that leg that's negative because we're dealing with the leg going down. Okay, but once again, we kind of already determined that it was a 45, 45, 90 triangle because we're dealing with a square root of 2 this time. So because we're dealing with 45, 45, that's what that little angle is. So we just need to convert it back into being a radian value, and that's going to be pi over 4. Now, here's the thing. When we're in the fourth quadrant, though, we were heading in a clockwise position, so that's actually a negative angle. So negative pi over 4. All right, so that was the inverse sine. Now let's talk about the inverse cosine. So once again, if I'm thinking about my graph, I got my graph from the unit circle. But once again, if you're looking at that cosine function, it's not going to pass the horizontal line test if I draw a horizontal line through that entire function. So once again, that means that we need to get an inverse by restricting the domain. So if you can see that we've got this darker piece right here over on the right. So let me even highlight it for you. So this piece right here, that is going to be the restriction that I want. So notice that it is a different restriction because it's all on the right side of the y-axis. This goes from 0 to pi. Okay, so we have a different restriction when we're talking about the inverse cosine. So here's my formal definition. So the inverse cosine function, denoted as cosine to the negative first power, is the inverse of the restricted cosine function y equals cosine of x, where 0 is less than or equal to x, which is less than or equal to pi. Therefore, we know that y equals the inverse cosine of x is the same thing as the cosine of y equals x. So that means if we're flipping then the x and the y around, 0 is less than or equal to y, which is less than or equal to pi, and -1 is less than or equal to x, which is less than or equal to 1. Once again, the 1's come from the unit circle where we know that the radius is 1. Once again, we're not actually going to be graphing the inverse functions, but I just want to relate it to the function with a picture. So one way to graph the cosine, the inverse cosine, is to reverse the ordered pairs, just like we talked about for the inverse sine. Okay, so notice that on the left is my original cosine being restricted from 0 to pi. So notice, flip it around. This time, the 1 and the -1 are on the x-axis, and the 0 to pi are on the y-axis. All right, so let's find the exact value of the inverse cosine of the square root of 2 over 2. So once again, inverse cosine. So that little -1 tells us that our final answer is going to be a radian value. But this time, my restriction for cosine is that 0 is less than or equal to theta, which is less than or equal to pi. So if you're thinking about a unit circle, that means that this time 0 is on the left and pi is on the right. So we're actually dealing with the first and the second quadrant. Okay. So when we are talking about, once again, all students take calculus, this time we're focusing on the top 2 quadrants there. So I'm going to determine what quadrant I want to draw a picture in based off of the ratio that they're giving me. Notice that my ratio is a positive ratio. So if I'm thinking about the first and the second quadrant, remember the first quadrant is where everything is positive. So I'm going to go ahead and I'm going to sketch a picture of a right triangle here in the first quadrant, where once again, theta is what we're trying to find. Because we're in the first quadrant, remember that means that if 0 is here and pi over 2 is here, that means that it's going to be some number that's in between those. So that's going to help us out as well. All right, so once again, if I'm looking at a ratio with a square root of 2, well, that means that this has technically been rationalized. It's 1 over the square root of 2. Okay, so if we're thinking about this time SOHCAHTOA, cosine is adjacent over hypotenuse. So we're thinking about 1 being adjacent, square root of 2 being the hypotenuse. Okay, we're talking about then a 45, 45, 90 triangle. Once again, theta is always going to be a radian value. So what's a 45-degree radian value? Well, that's pi over 4. And that would be my answer. Okay, if we're looking at the next one, inverse cosine of negative a half. So if I'm talking about having a negative ratio and I need to be focusing on the restriction that we're going from 0 to pi, well, I know that I can't be in the first quadrant because that's where all my ratios are positive. So this time we're talking about being in the second quadrant. So I know that I want to draw a triangle in the second quadrant. Okay, so notice that we're dealing with then a triangle where cosine is adjacent over hypotenuse. Remember, the hypotenuse will always be positive, so that means that my adjacent side is what's negative. So that means that over here is the square root of 3. So here's my triangle. Hopefully we're okay with noticing that it's going to be a 30, 60, 90 triangle. We want to figure out, though, which angle is going to be theta. So since it's across from the square root of 3, that means it's a 60-degree angle. And remember, 60-degree angle is really pi over 3. But now here's the thing. Pi over 3 is actually not my answer. The reason why it's not my answer is because pi over 3 is not an actual angle measure in the second quadrant. Remember, pi over 2 is up here, and this is pi. So in the second quadrant, that means I need an angle that's in between pi over 2 and pi over 3 is over here in the first quadrant. So this is where kind of we're thinking, okay, well, that was really then the reference angle. So if you're thinking reference angle, we need to then take my pi and I need to subtract pi over 3, okay? Because pi is the biggest number. When I subtract this reference angle, it's going to get me to here, which is technically this is the angle that I'm looking for. So think about pi as the same thing as like 3 pi over 3. When I subtract pi over 3 from it, I'm going to get the actual angle. So that ends up being 2 pi over 3. So just be very aware of what quadrant you're in, and is the angle that we're finding truly the angle that's going to be located in that particular quadrant. All right, so the last one we're looking at then is the inverse tangent. So once again, you need to have a horizontal line. It needs to pass the horizontal line test in order for us to then have an inverse. And because the tangent function already has some restrictions on the domain, each one of those will pass the horizontal line test. So we're going to focus on the one in the middle here in blue. So notice that because we have those vertical asymptotes, that means that negative pi over 2 and positive pi over 2 are not actually being included, but it's everything that's in between them. So here's my formal definition. So the inverse tangent function, denoted as the tangent of the tangent to the negative first power, is the inverse of the restricted tangent function, y equals tangent of x, where negative pi over 2 is less than x, which is less than pi over 2. Remember, the inverse means that we're really flipping the x and the y around, so tangent of y equals x, and that's where then negative pi over 2 is less than y, which is less than pi over 2. But look at my x values. Now my x values, when we're talking about the inverse, is negative infinity to positive infinity. And going back to the picture, hopefully that makes sense. Think about it. You're going up and you're going down. It's never ending for my original y's. So that's why when we're going to end up, and I'll show you in a second, flipping it around, that means that we're going to continue to go left and right, and there's no stopping point. So that's why we have negative infinity to positive infinity. Okay, so that's what I'm talking about. Here, my y's originally were going up and going down. So my y value was heading towards negative infinity to positive infinity. So when I flip it around, that's why my domain goes from negative infinity to positive infinity, because the arrows keep going to the left and keep going to the right. All right, so let's take a look at some examples. It says, let's find the exact value of the inverse tangent of -1. Okay, so once again, inverse tangent means that my final answer is going to be a radian value. The definition says that we want to go from negative pi over 2, which is less than x, which is less than pi over 2. So that means that, once again, if you're thinking about your unit circle, when we're going when we're going clockwise, that would be the negative pi over 2. When we're going counterclockwise, that would be the positive pi over 2. So very similar to the sine, we're talking about the first and the fourth quadrant. Okay, but these two values at the top are not actually going to be counted. It's just everything in between that. But with sine, those two values are included. All right, so we're thinking about our ratio. Notice that our ratio is negative. And once again, if you're thinking about all students, take calculus. If we're focusing on the first and the fourth, we are not going to want the first quadrant this time because that's where everything is positive. So that means we're focusing on the fourth quadrant, and we want to know what this angle is. Okay, so if we're talking about -1, that means that we're dealing with the same number. So -1 divided by 1. Okay, notice that if you're thinking SOHCAHTOA, it's opposite over adjacent. Well, opposite of theta is going down, so that's why that's -1. Here's my +1. Remember, when my two legs are the same, that means my hypotenuse is the square root of 2. Hopefully we figured out that we're dealing with a 45, 45, 90 triangle, where once again, my final answer needs to be then a radian value. So the radian value for 45 would be pi over 4, but because we're in that fourth quadrant, we're going clockwise, our answer is a negative angle. Okay, because remember, negative pi over 2. So when we're going in this direction, we're heading towards negative numbers. So negative pi over 4 would be that final answer. Okay, if we take a look at the next example, the inverse tangent of the square root of 3. So when I'm looking at my ratio here, the square root of 3 is a positive number. So because I know that I'm going from negative pi over 2 is less than x, which is less than pi over 2, and I'm thinking about the first and the fourth quadrant, I know that I need to be then dealing with the first quadrant. So I know that this is going to be a positive angle. Okay, so my ratio, if you want, you can think of it as over 1. Okay, so then once again, tangent is opposite over adjacent. So the square root of 3 is opposite. The adjacent would be 1. Hopefully you recognize this as a 30, 60, 90 triangle. And because that square root of 3 is opposite the theta, that means that it's the 60-degree angle. So it's positive because we are in the first quadrant. We moved in a counterclockwise position. So what's a 60-degree angle in radian value? Well, that's pi over 3. So there is my answer. Okay, so pause the video, see if you can do these problems. All right, so remember, inverse sine means you go from negative pi over 2 to positive pi over 2. It's included. But notice this time 0 means that it was a quadrantal angle. So if you're thinking about your unit circle, remember that ordered pair of 1, 0 on the x-axis, 0 is the second number. And what is the radian value located there? Well, that would be 0, because remember, pi over 2 is up at the top and negative pi over 2 is down here at the bottom. So theta is going to equal 0. In the second problem, when we're talking about the inverse cosine, remember you're going from 0 to pi, so you're either in the first or the second quadrant. Well, because we're dealing with a negative ratio, that means we're going to fall in the second quadrant. So remember, that means that pi over 2 to pi, that is going to be the range of my answer. So when I figure out what that theta is, that's not my final answer because that is smaller than pi over 2. So hopefully we recognize that when I see that we've got the cosine is adjacent over hypotenuse, we're dealing with a 30, 60, 90 triangle because because then 1 is technically across from theta. That means it's a 30-degree angle, so pi over 6. But remember then, that's the reference angle. So I had to subtract that from pi to get what the actual angle is in the second quadrant, and that's 5 pi over 6. Okay, so then with tangent, remember, you're either going from negative pi over 2 to positive pi over 2, but it's not actually including those numbers. So because we're dealing with a positive ratio, you're in the first quadrant. Technically, this square root of 3 over 3 had been rationalized. It was really 1 over the square root of 3. So remember, opposite over adjacent. So that's why 1 is across. And so we're dealing with a 30, 60, 90 triangle. And so in this particular case, then it's the 30-degree angle. So pi over 6 is my answer. Okay, so that's us understanding and using inverses without a calculator.